All right, how's it going? Today we will be talking about more stuff with bivariate data, two variable data, and we're going to look at something called a two-way table today. What does that mean? We will find out. First, I would like to introduce you to these 15 people whom I surveyed, and I asked them two questions. Do you like kickball? And do you like pickleball? Why did I ask them two questions? Because I wanted some bivariate data. Two questions, bivariate data. So this guy over here said, yes, I like pickleball, and yes, I also like kickball. She said, yes, I like pickleball, but no, I do not like kickball. She didn't like either one, and I got a bunch more responses from a bunch more people telling me two things: how they feel about pickleball and how they feel about kickball. So I got this data. Now, if I had to take this bivariate data and graph it, how would I do that? How would I graph yes, yes versus how would I graph yes, no? Which axis would be the pickleball axis and which axis would be the kickball axis? This data is not numerical, so how could I even put it on a coordinate plane? I can't. And so I'm going to take this data and I'm going to organize it in a different way. One way you can organize this kind of data, which is not numeric, is you can use something called a Venn diagram. You might have heard of a Venn diagram before or seen a Venn diagram before. It's where you have overlapping sections that helps you to organize information. For instance, I could take this guy and I could put him right in the middle where those two sections overlap. Why? Because he is in the red kickball section, but he is also in the green pickleball section. He is a yes, yes. The next person was yes for pickleball, but nope, not into kickball, and so on, and so forth, and so on, and so forth. By the way, why are these two people floating at the bottom? Because they didn't like either one, so they're not in either category. And a Venn diagram has insides and outsides, and we sort things out, and then we count. We have 3 people who only like kickball, 6 people who like both, 4 people who only like pickleball, and 2 people who don't like either one. So a Venn diagram is kind of a useful, helpful way to organize this kind of data. However, that's not what this video is about. This video is about two-way tables. So we're going to take the same data, we're going to organize it in what's called a two-way table. A two-way table is called a two-way table because it goes two ways. It goes by rows and it goes by columns, and we take our answer to the one question in rows and we take our answer to the other question in columns. So this guy who likes pickleball and likes kickball, I'm going to put a little tally mark right here because there's one person who likes both. Check. Then I'm going to make another tally mark for this person because she likes pickleball but does not like kickball. And I'm going to keep making tally marks for each person. And if you need to slow down this video, pause this video to see why I'm putting the tally marks in which spot. You can do that. For instance, this next guy likes them both. So I'm going to put a tally mark in likes. So does he. So I got 5 people over there and another one. This guy does not like pickleball, but he does like kickball. So that's why I put a mark there, etc., etc. Notice what we ended up with. The same 6 people who like both, the 3 people who were in that other part of the Venn diagram, 4 people, and then the 2 people who were outside of the Venn diagram completely. So this is what's called a two-way table, and it's just organizing your data in a table instead of in a Venn diagram. You can tell if you did your two-way table right by adding up some totals. For instance, how many total people liked pickleball? 6 plus 4 is 10. How many total people don't like pickleball? 3 plus 2 is 5. How many people like kickball? 6 plus 3 is 9. And how many people don't like kickball? 4 plus 2 is 6. You really know if you did your two-way table correctly if you find the total, the grand total, this way and it works, and this way and it works. If you did it all right, it should all work. 10 plus 5 is 15, 9 plus 6 is 15. There were 15 total people, and voila, we have a two-way table. You don't need the tally marks anymore. We just really care about the numbers, and the numbers should work. It's like a little puzzle, like a little Sudoku almost. And yay for us. Two-way tables are not too difficult. They're pretty straightforward. It's just like a little bit of a puzzle. And all of these people are very, very happy because they feel so represented. They all have a place in our wonderful two-way table. All right, that's pretty much all I need to say. The rest is up to you. So here is a practice problem, and I think you should probably pause this video and try to create a two-way table in your video notes today. Mrs. Wu surveyed 70 students about whether they prefer math versus science. That's one question. And whether they prefer ELA versus history. That's another question. Bivariate data, 2 questions. Of the 40 students, where's that 40 going to go? Who preferred ELA, 10 preferred math. 20 students who preferred science also preferred history. I see a 70, I see a 40, a 10, and a 20. Where are all those numbers going to go? That is up to you to figure out. So your task, complete the two-way table, and I will check these video notes tomorrow. Thank you, everybody. See you next time.